Welcome to BuildForce Canada's Productivity Series. Each episode will focus on one aspect of productivity. We hope you'll find them informative and useful as we all strive to improve our competitiveness. Remember, how we work is how we win.
This webinar is looking at some of the issues involved in measuring productivity in the construction industry. The principal argument or point of view in this presentation is that some of the conventional ways of measuring productivity in the construction industry, those that rely chiefly on Statistics Canada data, that's industry and sector based, can produce some dubious and questionable results. And so to look at the complexity of measuring productivity in the construction industry, we're going to go through each of the variables that constitute the equation for measuring productivity. And the reason for doing this is that if you look at the research literature on the construction industry, you'll find that there's a very extensive literature which concludes that in both Canada and the United States, these are separate research undertakings, that in both Canada and the United States, there's a serious productivity lag in the construction industry when you compare the construction industry to the manufacturing sector or to the rest of the business sector as a whole. And researchers will variously cite any or all of a number of reasons for that. The most common reasons that are often adduced to explain this purported productivity lag is a decline in the ratio of skilled to unskilled labor, so that there's an increase in the proportion of unskilled or semi-skilled labor in the construction workforce, and that trend is often associated with a decline in the union share of construction. That's a more common argument in the American literature. There's also a suggestion that there's been a stagnation in the quality of labor in the construction industry that is different from the quality of labor trend in the economy of whole. And in this case, quality of labor is proxied by educational attainment. So the argument here is that educational attainment in the construction industry has generally not changed very much over the last 10, 20, 30 years, whereas in the rest of the economy, we see rising educational attainment trends. It's also sometimes argued that in the construction industry, there's a lower capital to labor ratio. In other words, workers per capita use less machinery and equipment in the construction industry than they do in, say, manufacturing. That's sometimes attributed to the craft nature of many construction processes. Others have suggested that information technology and its absorption by different sectors of the economy has been one of the main drivers of productivity over the last couple of decades, and that the absorption of information technology in the construction industry has been much slower than in other sectors of the economy. And lastly, some have suggested that the use of prefabricated components in construction has increased significantly, and there is certainly evidence to support that, but that as a result of statistical conventions, the productivity gains which arise from using prefabricated components are assigned to the manufacturing sector and not to the construction industry itself. Those are the reasons that are therefore often cited for this purported lag in construction productivity. Well, the first question we have to look at is whether or not there really has been a significant lag in construction productivity, and what are the measurement issues that might arise when we try to explore that topic. One of the more comprehensive studies of construction productivity trends, and it's now somewhat dated, it was published in 2001, looked at construction productivity trends over quite a lengthy period of time, compared those to the business sector as a whole, and you can see in the graph here that the lighter line illustrates the trend in productivity in the business sector as a whole, and the darker line illustrates the trend in the construction industry, and the suggestion in this graph is that while there was somewhat of a lag in construction productivity from roughly 1961 to approximately 1981, problems seem to have developed just after 1981 when productivity trends in the rest of the business sector continued on their trajectory, whereas productivity trends in the construction industry actually showed decline. And that's usually the type of evidence that is cited by those who point to issues around educational attainment in the business sector as a whole compared to construction, or issues around the absorption of information technology. Well, what we need to do is look at construction productivity and the data that is used to support, first of all, the claim of a significant productivity lag. So the equation that defines productivity is pretty straightforward. Productivity is simply output in relation to resources used. It's not rocket science. Seems simple, but actually when you get into looking at each of those terms in the equation, it's more complex. First of all, we have to ask ourselves, what is the construction industry? Often there's simply an assumption made that when we talk about the construction industry, we're talking about the contract construction industry. You know, those are the various companies out there that are specialized in doing construction work. That's what people normally think of when we say construction industry. Well, statistically, the definition of the construction industry includes actually two components. The first component is, of course, this contract construction industry, but the second is what's called own-account construction, which is construction work that is undertaken by a company for its own purposes. That could be a mining company, a forestry company, a manufacturing company, or it could be a local or provincial government that is simply maintaining its own assets, its own roadwork, for example. And we don't actually have good data today on the share of the total construction industry that is represented by this own-account construction work. But if we go back to the 1990s, when statisticians did track that difference, we find that what's called own-account construction ranges from somewhere between 27 and 32% of the total construction industry. So that when we see these measures about productivity in the construction industry, we have to bear in mind that about a quarter to perhaps a third of the construction that is being measured purportedly by this analysis is actually not work that is undertaken by the contract construction industry. It's work that's undertaken on an own account basis. And it seems to me that that makes the analysis of construction productivity somewhat problematic, because one would not necessarily expect the same productivity trends to be present in own account construction as you might see in the contract construction industry, which is by definition much more competitive. The first term we need to look at in that productivity equation is productivity. What is it that is being measured? And there are different types of productivity that can be measured. We can measure labor productivity. That is the output per unit of labor input. We can measure capital productivity, the output per unit of machinery and equipment that's used. We can use multi-factor productivity, which takes both capital and labor into account, and also would take into account the role of management, the importance of infrastructure in supporting productivity. Could look at some of the design issues in the construction industry and what's sometimes called X-efficiency, which is the degree to which factors like competitiveness or monopoly or imperfect competition may tend to reduce productivity in some parts of the construction industry on a regional basis. The point here is that single factor analysis of productivity, and usually those single factor analyses focus on labor productivity, can be problematic because labor and capital are not independent of one another, and neither is independent of the impact of management or architectural and engineering design factors in the construction industry. When we look at output, we have to bear in mind that output could either be measured in physical units, but only if it's homogeneous. So you could measure, for example, the output in the roads sector by kilometers of road that are completed. But typically, output in the construction industry is heterogeneous, and so you have to measure it in value terms. The problem here is that if you're measuring output in value terms over a long period of time, you have to apply a price deflator because you don't want the impact of inflation to distort your analysis. And the problem in the construction industry is that the price deflators are notoriously unreliable. In fact, they're so unreliable in the United States, the Department of Labor, which manages the statistics on productivity, the Department of Labor does not even publish labor productivity data for the construction industry because it has very low confidence in the reliability of the price deflators that are used in the construction industry. It's also important to bear in mind in the construction industry that a very large portion of construction work is custom work. It's not commodity work. Every owner makes a decision in terms of a trade-off between aesthetics and cost. And design decisions are decisions that the construction industry typically has no control over. Those decisions are made by architects in consultation with the owner of what is being built. When we look at the resources used in the construction industry, because resources used is the denominator in the productivity equation, let's first look at labor. How is it that labor is being measured? Is it simply the number of workers, which is the most common, or is it the number of hours? And that's an important distinction. In the manufacturing sector, we can normally assume that the typical work week is 40 hours. There is some overtime, but in general, we can assume a 40-hour work week. Can't make that assumption at all in the construction industry. So, for example, in the institutional, commercial, industrial sector, for some trades, the standard is 36 hours per week. By contrast, in the civil sector, roads and bridges, utilities, and so on, the standard work week in the summer, which is the construction season, is 50 hours per week. Well, that's a very substantial difference. And so, if you're simply measuring the input, the labor input in terms of persons as opposed to hours, you will have a very different measurement of the input, and therefore a very different measurement of the actual productivity. And lastly, a good deal of construction work is not remunerated on the basis of wages, but on the basis of piece rate. And it's not at all clear how you would go about measuring the labor input in a piece rate situation where the worker himself or herself controls the number of hours and the amount of time they want to spend on a particular task. Capital is that by capital we mean machinery and equipment. Conventionally, it's the measurement of that input is the depreciation rate is used as a proxy. The problem with this is that it doesn't take account of obsolescence and scrapping before the usable life of machinery and equipment is exhausted, and often that can mean that the capital input is underestimated because of the statistical procedure. Lastly, and quite uniquely to the construction industry, site conditions are also very important. This is not an issue in the manufacturing sector where the environment is controlled, but in the construction industry, contractors have no control over factors like the terrain, the distance that's involved, or weather conditions. And these can be very important factors affecting productivity. Construction work, of course, is defined as being work that is undertaken on site. If work is done in a plant and then brought to the construction site, that work is considered to be manufacturing work, not construction work. So, for example, precast concrete, the manufacture of precast concrete is considered a manufacturing activity, although its installation would be considered a construction activity. If one is installing major ductwork in the sheet metal, the heating and ventilation industry, the installation of that ductwork will be construction, but the same workers, the same company, will be fabricating that work off-site and then bringing it to the construction site. It gets even more complicated in some large, heavy industry, heavy construction projects, where they may even set up some quasi-manufacturing operations on the construction site in order to supply the construction process. The statistical issue here is that when work is prefabricated, all of that prefabrication activity is classified as manufacturing work, not as construction work. And so you can have a situation, indeed you do have a situation, where the efficiency of building a structure is enhanced considerably by the use of prefabricated components, but the measured construction productivity is actually lower because all of the productivity gains are attributed to the manufacturing sector. Another factor to take into account is that the construction industry itself is not homogeneous. It's composed of a number of distinct sectors: low-rise residential, high-rise residential, non-residential building construction, the civil construction sector, pipeline, and so on. And the way in which that construction activity is undertaken is very different across sectors. The civil sector, the pipeline sector are very machinery and equipment intensive. The low-rise residential sector, not so much at all. And so the labor productivity across those different sectors will be very different. What that means is that you can have changes in the overall productivity trend in the construction industry that arise simply because of changes in the share of construction activity in each of those different sectors, and which have nothing to do with any underlying differences or changes in the productivity trend within the various subsectors that make up construction. Another factor to take into account when looking at construction productivity is that productivity levels in the construction industry, much more so than in many other sectors, are strongly sensitive to cyclical factors. The reason for this is that when there's a construction boom, when there's a shortage of labor and contractors and equipment, what tends to happen is that less productive labor, less productive equipment, less efficient contractors are drawn into the industry during the final stages of the expansion phase, and that tends to reduce the overall productivity of the industry. So when one is comparing, in particular, productivity levels across jurisdictions, be they provincial jurisdictions or national jurisdictions, it's important to bear in mind that differences in the stage of the construction cycle can have important impacts on that comparison. Another way of measuring productivity in the construction industry, and it is a procedure which has much more potential, I think, to give us real insight into productivity trends in the construction industry, is to look at activity-based measures as opposed to trying to measure overall trends in the industry as a whole. Activity-based measurements typically measure the output in physical terms, and they will use categories from the Construction Specification Institute's definition of construction activities. There are a number of published sources, that provide cost estimates. RS Means, Richardson, Dodge in Canada, Hanscom Yardsticks is one of the most common. These are available for general comparison. Some of the manuals are problematic because they rely on relatively small samples of actual costs, but activity-based measures provide much more insight into the actual trends than do measures that are based on attempted estimates of value. And it is interesting to note that activity-based measures of productivity are generally significantly higher than the value-based estimates of productivity. So some thoughts on how to proceed. Those who are studying productivity, I think, should generally avoid reliance on national accounts data on the dollar value of outputs. They should focus in particular on specific factors that may contribute to reductions or constraints on productivity, things like interferences through design inefficiency, the avoidance of idle time or site crowding through scheduling procedures, rework problems that arise when specifications are not clear, improve labor efficiency that can arise when you use a higher proportion of properly trained journey persons, and of course also site and climate conditions. It is also, I think, more useful to focus on specific construction activities, on specific trades, and on specific sectors, and to generate one's own data by looking at data from actual construction projects rather than relying on cost manuals. Thank you very much.
For more information and to watch the rest of our webinars, go to buildforce.ca.